Well, welcome back, folks. Today we're back to the Kawasaki F6 125. It's a 1972 model. Some of you may recall this project from about a year ago, where I had gotten it out of really storage or mothballs. This was a bike I bought new back in 1973. And the reason I worked on it a year ago is I had a leaking check valve in the oil injection system. And I had to pull this whole side cover off here that you can see to get at that leaking check valve, because it's buried up way up inside of there, inside of the case. And when I got in there, I discovered that I had a damaged gear as part of the Kickstarter mechanism. So I pulled it all apart, put a new check valve in it, replaced the gear, put it back together, and that was really the extent of that project. Well, late last season, and I ride this bike, or last summer anyway, I rode this bike about once a week or so around the yard, just puttered around the yard on it. Late in the season last year, just before I put it away, I noticed the clutch wasn't releasing. So when I pulled the clutch in and it was idling, as I was at a dead stop, I would put it in gear with the clutch in and the bike would stall out because the clutch wasn't releasing properly. Quite often you can overcome that by turning the engine off, pulling the clutch in, kicking it through several times, and that will, as often as not, loosen the clutch plates up, and then you're back in business. That doesn't work on this bike. The only way I can ride it is to, put it in gear and it'll lurch, and quite often it'll kill the engine. It's hard on the transmission. That's really not the way we want to do things. So I fiddled with it a little bit earlier this spring for a few minutes and tried to get it to free up, and I couldn't, so I decided I'm going to have to go ahead and do some surgery on this bike once again to get inside of that clutch package and figure out what's going on. There could be a couple of things, one, of course, being some broken clutch springs. I don't think I've ever encountered broken clutch springs, to be honest with you, on a bike that wasn't abused, and this bike certainly was never abused. It's possible, certainly, though. It could be that the clutch plates, particularly the fiber plates, are just sticking together and just the springs can't overcome that. So that might require replacing of the fiber clutch plates and or the clutch springs, especially if some of the springs are broken. I won't know until I get in there. What we're going to have to do in order to get at the clutch is I'm going to have to take this entire cover off. That Kickstarter has to come off. That little cover right there covers the oil pump, and that'll have to come off so I can disconnect the oil pump line, or the oil line that comes down from the oil tank to the pump. Behind this cover is the carburetor, so this cover has to come off, and the carburetor has to come off, and then we can get at the internals to get at the clutch, which is right behind this part of the cover right here. Now, this is a rotary valve design. It's one of three common intake methods used on two-strokes. That would be piston port, reed valve, and rotary valve. Kawasaki was a big user of rotary valves back in the day. Actually, all three of the main two-stroke manufacturers, that being Kawasaki, Yamaha, and Suzuki, used rotary valves at one time or another. Suzuki and Yamaha primarily on their smaller single-cylinder bikes. Kawasaki was a little bit more prolific with using of rotary valves. They used them all the way up through the 350 Enduros, and they actually even used them on a couple of twin-cylinder street bikes. The reason one uses a rotary valve is it allows very precise control of the intake charge, the fuel charge timing as it's introduced in the lower end of the engine. Now, I'm not going to go through a whole theory of two-stroke engine operation here, but suffice it to say that a rotor valve is used typically to allow for precise fuel charge intake. The disadvantages to a rotor valve design is it's more complicated. That's why I've got to pull this whole carburetor assembly off to get the cover up, the side cover off, to get at the clutch. It forces typically the installation of the carburetor on the side of the engine behind this cover, rather than mounted or bolted to the back of the cylinder like you would normally see here on a piston port or reed valve design. So it's a bit more complicated to repair. Certainly, I'm sure they're more expensive to manufacture, but they do allow for some precision on intake timing. Before we go ahead and start pulling this engine apart, and I will show some of that here, let's go over to the computer, and I want to just briefly show you what a rotary valve looks like, because I'm not sure everyone watching this video perhaps has seen a rotary valve and knows what it looks like. I'm not going to be pulling the rotary valve out of this bike, so when I pull the side cover off to get the clutch, you won't see the rotary valve because it'll be behind another cover. But we'll take a look at an example of a rotary valve here on the computer in just a second. We're over at the shop computer right now, and you might notice a little bit of fan noise emanating from the shop computer from time to time. I think it's going through some update, some maintenance right now. In any event, this is a typical rotary valve. This does happen to be off Kawasaki. It looked very similar to the one that's installed on my F6 we're going to be working on here in a few minutes. These are often made out of a composite or a fiber material, though not exclusively. They could be made out of a metal. You'll notice the hole here in the middle that's keyed right here, this little notch. It's keyed to fit over a pin or a key on the end of the crankshaft, which ties the whole unit together. And this rotor valve spins with the crankshaft, consequently. You can see the notch at the top. That is actually, that's the where the induction takes place when the valve spins, and this cutout section passes behind the mouth of the carburetor. It allows the intake charge from the carburetor to be drawn in by the vacuum of the crankcase of the engine and sucked into the lower unit, and eventually end up in the upper part of the cylinder. I mentioned earlier that in addition to Kawasaki, Suzuki, and Yamaha had used rotor valves. I'm not aware of Honda ever using them, though Honda did in fact make some two-strokes, smaller two-strokes. I don't, to my knowledge, believe Honda ever used a rotor valve. I think those are all piston-ported engines to the best of my knowledge. In any event, very typical rotor valve design. And if you ever pulled one off of almost any small single rotary valve engine, it would probably look very similar to this. Let's go over to the bike, and we're going to go ahead and begin the removal of the side cover. And I'm going to start by draining the transmission oil, and then we'll move on to the mechanicals. We've got the side cover off, and as you can see, it's weeping a little oil yet, transmission oil down underneath here. That's why I put these diapers down first to absorb any of that oil. So what I'm going to do now is let it just drip dry for a little while, get most of that oil out of there, and then we're into the engine as far as we're going to go right now in terms of disassembly, with the exception of the clutch itself, and that's what this is here, the clutch basket. The rotor valve I was talking about earlier is behind this cover. In order to get at that, there's quite a bit more disassembly you'd have to do besides removing the whole clutch basket. The drive pinion, there's a cover here that covers the rotor valve. The rotor valve is right in here. In fact, you can touch it. There's some seals in there, some O-rings, etc. Not a huge job, but it's probably another 20 minutes to half an hour at least to get inside of that. But I don't need to go there. I'm going to let this just drip for a few minutes, and then we're going to end up getting into this clutch. I've never had this clutch basket apart before, so it'll be the first time I've ever had to get in here, and we'll see what's going on. So we'll be back in a little while. It's been about 10 minutes or so since we pulled the side cover off, and I've got all those parts out of the way and put aside in a nice safe place so they don't get banged around or dirty. A couple of things I want to talk about here briefly before we move on and start pulling this clutch assembly apart. You'll notice I've got the rear brake lever just pulled down with a bungee cord. I don't know if you can see that or not here. Got that pulled down and out of the way just to clear the side cover. I did not want to bump into that when I slid the cover off. Probably could have got by without it, but I wanted it out of the way. The oil line, the oil feed line, the oil pump, you can see I just got tied up out of the way here with a zip tie. The plug that I put in the end there is just a silicone plug that I use for powder coating. It's just about the right size. And also the foot peg here, I just loosened the nut up and rotated that down also to allow me to easily pull the side cover off without having to maneuver around it again. Probably not absolutely necessary, but it's just a little easier that way. Fuel line is just tucked up out of the way. Carburetor is tucked up out of the way. And I think we're about ready to get into the clutch. As I indicated earlier, I've never had this clutch apart before. I've never had to. Oh, by the way, point out right here where I'm pointing to with my finger. That's that oil injection pump check valve that I replaced a year ago. That's it right there. The clutch plates are held on with these 8mm headed, those are 8mm heads, not 10 bolts. There's 5 of them. You also notice they've got a cross cut in them for a Phillips style screwdriver. But since they're hex bolts, I'm just going to use this socket, 6-point socket, just because I don't want to take a chance of damaging those cross recess there with a screwdriver. And these should come apart pretty easily, I think. They aren't usually torqued very tight on the small little bolts like this. So we'll just loosen them in a bit of a crisscross pattern like you do when you were torquing something. And they will typically have tension on them almost all the way out because of the springs behind them. So these bolts are now loose, all of them. And I can just take them out as assemblies. You'll see there's a bolt and a washer. Well, none of them appear to be broken. So it looks like that's not the problem, though they might be below their service limit. We'll check that later. There is specification on the spring length. That being this length, there is a specification on that I have. So we'll check the spring length on them a little bit later. Now we've got to go ahead and get this lifter plate off and get the clutch assembly out. There's a lifter right there. There's a rod that comes through the middle here from the opposite side of the engine that pushes on that lifter and allows these clutch plates to separate. And there's the clutch back. And they are stuck together. They are stuck together pretty good. So we'll take these over to the bench and we'll do a little bit more up close review and decide what we're going to do next. We're over here at the bench, and I have not taken the clutch assembly apart. I have taken some photos of both sides of the clutch, this side, but as you can see, I have not taken it apart. It's just as it came off the bike. There's two different kinds of plates in here. For those of you who are not familiar with clutches, there's a what they call the steels, or a steel plate. That's what this is. And there's a steel plate every other plate, and then you have the fiber plates. That's what these kind of the reddish brown is right here. And in this clutch, I think there's 4 of each. There's 4 steels and there's 4 fibers. So they're typically, it's, as I said, it's a every other one. So there's a steel. I'm going to go ahead and take this apart. There's a fiber, then there should be a steel, and a fiber, all the way down. See, that one doesn't want to come apart very easily. These are in very good shape though, these steels. Quite often you'll see wear marks, or you can just tell that they've been well used. Again, this is the original clutch on this bike. You'll notice I'm keeping them in order as I take them apart. So far I don't really see anything major here. In terms of wear, damage, there's no rust. I wouldn't expect there to be any rust in this bike because it's always been kept inside and well cared for. So I'm not really seeing anything that jumps out at me. I think what I'm going to do is clean these all up and get all the transmission oil off of them and get them dry. Then I can do some measuring. What I'll probably end up doing is end up replacing the fiber plates, but we'll see. You can get all these parts yet from Kawasaki. You can get all the clutch plates, both kinds, and springs new. They still offer them, supply them, and of course they're all over on eBay. Kind of expensive. If I was to replace all the clutch plates and the springs, it'd be around $160 US. A little pricey. Not sure it's necessary either right now. So I'm going to go ahead and get this cleaned up and let them dry. It might be a day or so before I get back to this, and then we'll do some measuring and see what we got in terms of wear or any other issues. But there's nothing that I can see clearly right now that indicate that we have a major failure within the clutch. So let me clean these up and we'll get back. It's actually quite a bit later in the same day is when I shot the earlier portions of this video. I have all the clutch components cleaned up thoroughly, and then I put them out in the sun to dry for a few hours. I want to make sure everything was completely dry so that I can go ahead and complete a series of measurements and do some visual inspection. Starting with the most obvious, I really don't find anything wrong, to be honest with you. I don't see any abnormal wear. There's nothing broken. Everything looks as I would expect it to be. The steels, that's these clutch plates right here. There's actually, I think, 5 of these. I may have indicated there was 4 earlier. There's 5 of them. And there's not even any real signs of wear on any of them, as you can see here. The lifter plate itself is perfectly fine. Again, there's no wear of any kind to speak of there. And on the lifter itself, which separates when you pull on the clutch lever, rod goes through and takes the pressure off, or pushes the springs back to take the pressure off, is in good condition. You can see a little bit of indentation on the end there from there's a ball bearing in there that pushes against this rod. That's normal wear, and that's nothing exceptional. So in terms of these parts, I see nothing wrong. Same thing with the springs. They cleaned up real nicely. 5 of the springs, none of them are broken, which was one of my first concerns. And for the friction plates, the composite friction plates, they all look perfectly fine as well, and there's 4 of these. So what I'm going to do now is measure some of these components. Kawasaki does provide some service information. For the springs, the standard length is 34.5 millimeter. The service minimum is 31 millimeter. In other words, they should not be smaller than 31. Let's get our dial caliper here set up, and you can see I got it zeroed out at 0. And we'll measure a few of these here and see what we've got. And that's just shy of 33. So certainly it's underneath the standard size, but it's well above the minimum. This one's about the same, just shy of 33. You got to be careful when you measure these that you don't compress the spring. That was a little bit shorter than the other 2. Same thing there, just short of 33. So well within the service limit, certainly. That's 31. There's really nothing obviously wrong with the springs. Now, Kawasaki does not provide, at least I couldn't find it, any service information or limits for the steels in terms of size. The only information I could find in my service manuals was for the friction plates. That's these fiber plates. 41 or 40.0 millimeter is the standard. The minimum is 3.6. So again, we'll measure these. You can see these are awful close to just under 4 millimeter. Well above the 3.6 minimum. They're all running about 3.9 millimeter, thereabouts. So the friction plates are all within factory specifications as well. None of the ears are broken off either. Now what you can do to revive clutch plates is you can scuff them up, and that is you just put a piece of fine emery cloth or sandpaper on a very flat surface, piece of glass or surface plate, and just scuff them up a little bit to take the shininess. You can see just a little bit of, maybe there, a little bit of shininess. You give them a little bit of grip, because these are the friction plates after all. You can do that to revive them, but what I think I'm going to do is I'm going to replace the springs in the friction plates. And the reason I'm going to replace the springs, even though they're well within specifications, is they are 50 years old and they have been in a compressed state for 50 years, and I'm not sure how strong they are anymore. So I'm going to order new clutch springs, and I think while I'm at it, rather than scuffing these up and trying to salvage them, which probably would work, I think I'm just going to order new friction plates, a set of 5. And then I'm also, I think, going to go to one step lighter weight transmission oil. I think I'm going to go to a 75 weight Bel-Ray 2-stroke transmission oil rather than, I think I used 80 in this bike. That's usually what it uses, 80. I'm going to go one notch lighter in that. My suspicion is it's a combination of the springs are just weak enough, the plates are just, these friction plates are just worn enough, and that 80 weight Bel-Ray is heavy enough or thick enough that It's not allowing the clutch springs to overcome the stiction when those plates stick together, and prevents the clutch from being able, the plates from being able to release. That's my theory. So I'm going to go ahead and order some parts. It'll probably be at least a few days, if not a week, before I get them in, and then we'll pick up this video in part 2 at that point. That's going to be it for this video today, folks. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.